All right, everyone. Here are the notes, or at least highlighted notes for these sections here for 10.1 and 10.2 for day 6. All right, there's a lot we're going to look at. All right, we're going to look at area for a lot of these shapes, and so yeah, we'll get into it. All right. Okay, so the area of a rectangle we know is base times height, or length times width. For this section, we're going to use base times height because that's the same for an area of a parallelogram. All right. Please note that the base and height must be perpendicular. Right. So a common mistake that I've seen over the years is people will think that this diagonal line is the height. No, that's not the case. All right. The height is always perpendicular to the base. And you'll note that in some of the examples we're going to look at, sometimes you have to figure out that height. Okay. All right. So here are a few examples. I think there's a bunch of these examples that I copied and pasted here. Take a look at these examples. All right. Here for this one, the base is 6. Okay. And the height is this height right here, right? Or we can see from this corner B, right, along this y-axis, this is perpendicular, all right? That's a unit of 8, all right? And over here, okay, here is the height, all right? It's perpendicular, it tells you, and your base is 8, okay? So the 10, listen, the 10 would be the base if the height is here where I'm highlighting, okay? Maybe if I draw that in real quick, all right? If the height was this right here, the line that I just drew in, if you knew this height, then you can use 10 as the base, okay? But you don't, so we're going to use 12 as the height and 8 as the base, all right? And so it might be, in number 6 and number 5, the height is outside, but if you think about it, that same measurement of 2 meters here can be the same over here inside, all right? And just a few more examples here, like I said, you have to solve for h, all right? Those come in various forms, all right? Okay, so in number 7, there's a setup here, right? Because if we use 11 as the base, then 14 is the height, right? And then that would equal the same area because it's the same parallelogram. If we use 22 as the base, then h is the height, right? So we set these equal to each other. So take a look at these examples 7, 8, 9. I think that'll be helpful for you to look at. And then more of these, and we're incorporating special right triangles. Okay, got to know how to use the 45, 45, 90 and 30, 60, 90 triangles here. If you have questions about these, please shoot me an email in the morning. Okay, and hopefully you can follow these along. All right. So let me go over number 12 real quick. Number 12, you notice, how do you know if this is 45 degrees here? So you learned a couple sections ago, right? Properties of parallelogram. This is 135, right? Then consecutive angles must be supplementary. So if this is 135, then this angle here is 45 degrees. And so therefore, if this is a 90-degree angle, then this is a 45, 45, 90, okay? The 14 is the hypotenuse. And if you know the hypotenuse for a 45, 45, 90, then how do you figure out the legs? You take that hypotenuse and you divide it by √2. All right, and then you have to rationalize, and after the process, you end up with 7√2. So that's the height here. Okay, so that's how we get 20 times 7√2 for this problem. All right, please, you should leave your answers in simplified radical form unless it asks you to round. Okay. In this problem, this is another one of those ratio problems, right? So the base and the height are in a ratio of 5 to 8. So we don't know exactly what those measurements are, but we just know the ratio. And so we know that this is going to be 5x times 8x. Okay, all right, and so that equals 360 in this problem because that's what the area equals. All right, and so through algebra work, we divide by 40 and we take the square root. X is equal to 3. All right, and so since x is equal to 3, you have 5x and 8x, and you substitute to get 15 and 24 here. All right, similar problem. Okay, it says the angles has a measure of 45 degrees. Find the area of the parallelogram. Okay, you know the base is 16. All right, if 8 is the hypotenuse, then again, using your knowledge of 45, 45, 90, you can figure out this height. It turns out to be 4 root 2. All right. We know the area of a triangle is 1/2 base times height. But in these 3 examples, look at the different ways. All right. So here the base is 12, right? And the height is perpendicular, remember, and so we're going to use 8 as the height. Okay. If you want to use 17 as the base, then you need a height from this corner down here, but we don't know that. Okay, so that's why we use the 12 as the base and the 8 as the height. Number 16 is a scalene obtuse triangle. All right, and so we're going to use this base of 15. Please note that we are not using 18. All right, 15 is the base. It's the segment. It's one side of the triangle. All right, the height is 4. Okay, and when it's outside like that, that's okay for an obtuse triangle. All right, for 17, this is an acute triangle, right? Meaning all of the angles are less than 90 degrees, and so therefore the height is going to be inside the triangle here. All right. For these problems, you have a mixture. All right. I'm going to go backwards. Number 20. If you look at the blank notes, you can see what the original shape is, but you know, you can extend these lines and you can split these into 3 separate areas here. Okay. For this one, for number 19, you have the area of the parallelogram. Okay. And then the area of the triangle. Okay. And I believe we added those 2 together. All right. Okay. And then here we split it, right? We drew in this dashed line to create a square. Okay, that's why you have the area of the square. And then you have the area of the triangle here. Okay. So here I scratched out, these were the answers from the previous problem, but I would say this is a very, very good example to go over. Hint, hint. All right, you got to remember how to graph. Y equals x plus 2, intercept at 2, slope of 1. All right. Y equals 2. Remember, that's a horizontal line. So at 2. X equals 6 is a vertical line. All right. And so it creates this triangle. All right. And so we're asking you to find the area of the triangle formed by these 3 lines. All right. And then, as we keep moving on, all right, we're going to look at area of trapezoid in 10.2. All right, the height of a trapezoid is perpendicular distance between the bases. Okay, so again, perpendicular. And here's the area formula. Right, the area of the trapezoid is half the product of the height and the sum of the bases. All right, meaning, well, right here, I think this is any of this is helpful right here. Okay. So the height times, you're going to add B1 and B2, and then divide by 2. All right. Be careful of order of operations, of course. All right. I would break it down before putting and trying this all on your calculator at once. I would add these bases first, and then multiply by the height, and then divide by 2. That's just me, though. And so here's a few examples, pretty straightforward. You know what the bases are and the height. Okay. Here, I think you have to, we have to figure out the height. If this whole base is 14, and if you know this is 8, then the leftover is 6. And so if this is 6, and I believe you were given a 45 degree, this height must be 6 as well because of a 45, 45, 90 triangle. A couple more examples here. Again, using the special right triangles for 30, 60, 90, all right, depending on what you're given. Okay, so here, I think you have to figure out the height. You're given the bases of 5 and 7, right? And again, if this whole thing is 7 and if this is 5, this must be 2 that's left over, right? Well, the 2 is across from the 30 degrees, which means that's the shortest side. Then the medium side, right, is going to be the 2 times root 3. So that's the height, okay? And so that's how we got the 2 root 3, okay? Same thing over here. Special right triangles to get 4 root 3 for this height, okay? So this is the height here because the bases are 7 and 11, okay? You got to know the area of a kite. Okay, here's the formula, 1/2 times the diagonals, d1 times d2, all right? The diagonal 1 and diagonal 2, all right? Okay, so again, I think these are pretty straightforward. All right, again, number 7, you might have to use some special right triangles, 30, 60, 90, okay, to figure out here, this is 4 root 3, okay? This was given to you as 8 root 3, so the whole diagonal is 12 root 3. That's how we got that. All right, it's not 12 root 6, okay? Don't add the numbers inside the square root sign, okay? You only add the numbers on the outside, okay? For a rhombus, same formula, okay? You 1/2 times d1 times d2, okay? All right, you might need to use Pythagorean theorem sometimes to figure out a missing side or a missing part of a diagonal. So take a look at these examples here. And number 10, you're given the perimeter, all right? And so you know that each side must be 25, I believe. You know what? This is a typo now that I'm looking at it more carefully. All right, 200 divided by 4 is not 25. That should be 50. Okay, so that's an error on our part. Okay, but hopefully we still understand the idea here. All right, over here for number 11, you have to figure out what x is. Okay, we have x squared plus 5 squared is equal to 8 squared. Because remember, the diagonals of a rhombus intersect at 90 degrees. Okay, so if the 90 is here in the middle, well, middle-ish, then 8 must be the hypotenuse. All right. And then here also find the area of each figure. Okay. This looks a little confusing for number 12, but this is the trapezoid formula, I believe. Okay. 1/2 times 12, the height. You have to figure out the height here. You can do x squared plus 16 squared equals 20 squared. All right. And then you got to add 14 and 16. All right, that's what this is, 14 plus 16. That's this base plus the other base, right, times 1/2 times the height. Okay. Here in number 13, you got to use special right triangles again, all right, to figure out this part of the base and this height, right? And then here, again, 3, 4, 5 triangle. If you don't recognize it, use Pythagorean theorem because for a rhombus, diagonals intersect at 90 degrees. All right, and on this last slide, again, here's a ratio problem. Okay, diagonals of a kite are in the ratio of 3 to 2, so that's going to be 3x times 2x. You set it equal to 27 using the formula here, all right, and then we work it out, all right. If you have any questions, as always, please shoot me an email. And the nice thing is you will have a formula sheet for this quiz.